true. Okay, so this is example how it is actually executed. So say two integer with a is equal to 10 and b is equal to 10, 12. So this is binary. So we have to operate bit by bit. So first a is 10, so 1010, that is 10, and b is 12, so 1100, that is 12. So this is a index for first, second, third, and fourth. So now 0 bitwise operator 0, output is 0. 1 bitwise 0, output is 1. So 1 0 1. 0 bitwise OR operator 1, that is also 1, so the output is 1. And 1 bitwise operator 1, that output is 1. So when you get this bitwise operation, you got answer as 0 1 1 1. So this is nothing but 14 in decimal. So this is the output when you execute bitwise A or B. You can also check with the help of this student. B is equal to 10 and answer A bitwise operator B. Let's execute this. So answer is 4. Okay. Now what is the use of bitwise OR operator? Let's take a scenario where we are going to design a robot car which use a sensor to sense the environment and update its direction accordingly, like direction left, right, forward or backward. So we are going to use 4 bits to represent for each one direction. So there is a bit position 1, 2nd, 3rd and 4th. This is the sensor status. If this first bit indicate right, second bit indicate left, third bit indicate forward and fourth bit indicate backward. So whenever the sensor wants to update any status, it will use the above 4 bits and says the status. Like if the sensor set first bit as 1, which indicate that the car should turn to the right direction. So here we should to enable bits according to the sensor input. So that is the use. Then how will you enable specific bit programmatically? So using bitwise operator, we can enable a specific bit. Example, let's assume the sensor sense something and it wants to indicate the car to take the right direction. So we need to enable first bit as 1 for right direction, because first bit is reserved for right direction, like this, first bit for right direction. To update the bit status, we need to create a binary OR mask in which we show only 1 in the right direction position, all the values are 0. So like in this case, OR mask 0 0 0 1. Why last bit digit is 1? Because we want specific digit 1, that is a this bit specific bit 1 indication right turn. So that's why this is the OR mask. Now take sensor status OR mask, like sensor status 0 0 0 0, and if you put mask with 0 0 0 1, then sensor status bitwise mask operation, that will give you this 1. That means right direction bit has set to 1 with the help of this OR mask. Similarly, if you want to enable left direction bit, mask will be 0 0 1 0. That means left 1, this 1. Now left 1. So second digit is 2 1. So mask will be 0 0 1 0, and remaining all are 0. So now the sensor status bitwise or mask. So sensor status mask operation. So sensor status bitwise operation mask, that is equal to 0 0 1 0. That is left direction bit as set as 1. Hope you understand this. Now we move to the next bitwise operation, that is a bitwise AND operator. So and this is the same, that Truth table of AND logic operator is same, that is AND 0. If both are 0, output is 0. If and only if output is 1 when both input are 1. So but it runs bit by bit. So bitwise AND operator will take two equal length binary sequence and perform the bitwise AND operation on each pair of bit sequence, and operator will return 1 if both bits are 1. Otherwise, it will return 0. This is a truth table. So let's do the example. Say A is equal to 5, B is equal to 9. So A equal to 5, 0, 1, 0, 1, and B is equal to 9, 1, so 0, 1. So what is the result of A and B? So let's do this. 1, 2, 3, 4. So A 5, B 9. So 1 and 1. Now bitwise AND operator. So 1 and 1. Output is 1. 0 and 0. Output is 0. So 1 and 0. Output is 0. And 0 and 1. Output is 0. So in this case, that means A bitwise AND operator, B indicate our output is 1. So A and B will 1, which is decimal value is 1. So 0, 0, 0, 1, the decimal value is 1. So this is example. Let's same thing in the Jupyter notebook. So yes, so 5, 9 AND operator, bitwise AND operation, output is 1. Okay, so what is the use of bitwise AND operator? So we already discussed the previous example where we can update the direction status of the car robot. In order to turn the car to the specific direction, we need to check which direction bit is enabled. So let's assume that sensor update the right direction bit is on. Right means last is 1 is 1. So backward 0, forward 0, left 0, right 1. So this is the use of this particular bitwise AND operation. So how will you check whether the first bit is on or off? So with the help of using bitwise AND operator, we can check the particular bit has enabled set to 1 or disabled set to 0. To check the bit status, we need to create a binary AND mask as we have created earlier in or binary OR mask. So AND mask should have only 1 in some position where we are supposed to check the bit status. Like we have to check bit status for right direction turn. That's why we have to set last digit as a 1 and should be remaining bit as a 0. This is an example. Here we are going to check the first bit status. So mask will be 0, 0, 0, 1 because 1 in the first bit and remaining 3 bits are 0, that indicate a right direction turn. So now calculate the sensor status bitwise AND operation mask. So sensor status is this 0, 0, 0, 1. Now we need to check whether there is a turn right direction is set in the sensor status, yes or no. So mask is 0, 0, 0, 1, and then sensor status bitwise AND mask operation. So 1 and 1, only 1, otherwise all the operations are 0. So yes, the answer is 1, which indicate the car should change its direction to the right. Similarly, left check for the left direction, which is second bit. So mask at the for that we have to set mask and mask as 0, 0, 1, 0 because left this is set to second position or second index. So remaining are bit are 0. So now get to sensor status and bitwise operation mask. So 0, 0, 0, 1, 0, 0, 1, 0. Now 1 bitwise 0, 0, 0 bitwise and 1, 0, 0, 0, 0, 0, 0. So now the answer is 0, which indicate that this car is don't turn in the left direction. Okay, so that is a very good example that we can see here. Now third one, bitwise XOR operator. So first XOR operation, logical truth table as per the given that AI and BI. So whenever on or XOR like XOR gate, whenever both the digits are same, output is 0. And whenever both for the two inputs, assembly conceivable, when both the input are differ, then output set to 1. So 0, 0 output 0, 0 and 1 output 1, 1 and 0 output 1, and 1, 1 output 0. So either of any one is on, then output is on. But when both the bit either on or either off, means both the condition is the same, then output set to 0. So bitwise operator will take two length sequence by sequence and perform bitwise XOR operation on each pair of bit sequence. XOR operator will return 1 if both bits are different. If bits are same, it will return to 0. These are two tests. So let's do the same example with 5 and 9. So this is already digit for 5 and 9. So 5, this is 9. So now check 1, 1. So same digit. So output 0. 0, 0. Same digit. So output 0. 1 and 0. Now digits are different. So bitwise XOR operation is 1. And 0 and 1 here same, digits are different, so output is 1. So when you compute in the term of decimal, that output is 12. So A bitwise XOR operation B will be 1 1 0 0 in binary, which is 12. So we can also check in the notebook. Yes, so this is the same answer we have received. So the interesting fact is that if we again perform XOR on the above result with 9, we will get 5. Like this, result is 12, so 1 1 0 0. Now B, what is B? 9. So 1 0 0 1. So what is the output? So 0 1 1, both are different. 0 0 same, so output 0. 1 0, both are different, output 1. And 1 and 1 same, so output is 0. So now you can check the result output is 5. So we get value of answer A. So because of this property, bitwise X operator was used in cryptography. How it is used in cryptography? Let's understand with this example. Like assume that if 5 is the value that we want to send to another person confidentially, but if we send message 5 directly without any modification, then the secret will be question mark. Because if you want to send directly that is digit 5 to that another person, then there is not any kind of security. To avoid that, the two persons will share some secret key, which is only known by this 2. Let's take secret key is 9. So before sending the message, the sender will XOR the message with the secret key. So 5 XOR 9. 5 XOR 9. Then the increment message will be sent. So increment message sent is 12. After receiving, or after receiver got the message, what receiver got the message? 12. He will decrypt using the same key. So 12 using same. So 5 is okay. So here 9 is this. 12 secret key is 9. So 12 XOR 9. So he will receive the answer 5. So it's the same key or original message. So this is the very useful use of bitwise X operation initially in the cryptography. This is a weakest, you can say, a cryptography message. Nowadays, very well advanced cryptography is there. So this is the example, like standard encryption, secret key 9, message 5, encrypted message 5 XOR 9 is 12. So 12 will be sent to the receiver rather than the actual message 5. Now receiver is decryption. So secret key is same in the both the case, 9 and 9. So message received 12 is the output. So original message 12 XOR 9 and message is 5. So this is one of the weakest cryptography method. Okay. So now next is bitwise left shift operator. Bitwise left shift operator is used to shift the binary sequence to the left side by a specific position, like say 1, 2. So example, let's take number 14. So binary representation 14 is 0 0 0 0 1 1 0. So here we have used 8 bit because of clarity. So now 14 in terms of binary is 4 times 0 and then 1 0. Then we want to shift left by 1 operator. Then what is the answer? Let's do with this particular figure. So 14, 0, 0, 0, 1, 0. Now left shift. So now 0 shifted by this position. So 0 shifted by 1, then 1 shifted by left position. Similarly up to the last digit. So now this place is empty. So whenever empty box will be there, mark with 0. So now when you compute this is equal to 28. So actually 14 is there. When you left shifted by one position, then you got 14 into 2, that is 28. Now another time you have to shift that from this position to left by 1, or say 14 by 2, 14 left shift by 2. So 0 shifted by once again, then 1 shifted once again left side 1. So similar kind of thing, left side. So when an empty box will mark as a 0. So at that time you got answer as 56. So 28 into 2, or you can say 14 into 2 into 2. Okay. So there is application of bitwise left shift operator. So in above diagram we can notice that whenever we shift the number by one position to the left, the output will be exactly number multiplied by 2. Like in this case 40 multiplied by 2 when we shift 1. Here we shifted by 2. So 40 multiplied by 2 multiplied by 2. So 40 multiplied by 4. So this 6. So if we shift 40 by one position to the left, output will be 14 to 28. And if we shift 40 by 2 position to the left, output will be 14 into 14 by 56. So in general, we shift a number by n position to the left, the output will be multiplication of 2 raised to n. So this is the example. So let's assume the number as 12. If we shift the number 3 position to the left, then the output will be 12, that is flip shifted by 3 position. So 12 into 2 raised to 3, because we have shifted by 3 position, the 2 raised to 3, that is 8. So 12 into 8 is equal. So that is the answer 96. And this is the program using bitwise left shift operator. You can check with the help of this, like variable 2 is there. So print variable 2, same number is there because it's 0 shift. Let's see this. So variable 2, then you can see that variable 2, the 0 shifting, so answer is same. In next case, when we shifted by one position, then that is equal to variable into 2 into 2. So that's why it's 2 into 2 is equal to 4. So you can see one by one and get your answer easily. So 2 into 4 is, and then 14 10, that is a 16, then 32, then next is 32, then it is equal to 64. So that is okay. So bitwise right shift operator. Bitwise right shift operator is used to shift the binary sequence to the right side by specific position. Like earlier case, we have shifted by left position. Now in this case, we have shifted by right position. So earlier case, we have multiplied the number with 2. In this case, what is there? Obviously, that is a division in this case. So let's take a number 14, same with example 0, 0, 0, 0, binary position. When we right shifted by 1, then 14, this is sequence 4 0, 4 times 0, 0, 14 right side by 1. So that is a 7. So that is equal to 7. So 14 divided by 2, that is equal to 7. When 2 time right position, then that is equal to 3. So 7 divided by 3 point, actually 3.5 there, but there is a integer value, so answer is 3. Okay, so application of bitwise right shift operator is that in the above diagram you can notice that whenever we shift the number by one position to the right, the output value will be exactly number divided by 2. If we shift 14 by 1 to the right, 14 by 1 position to the right, output will be 14 by 2, that is 7. If I shift 14 by 2 position to the right, output will be 14 by 4, that is 3, but actually it is 3.4. Since it is an integer, fractional part will be not be considered. So in general, if we shift the number by n times to the right, the output will be number divided by 2 raised to n. Okay, I hope you understand. So let's assume the number is 128. If we shift to number 5 position to right, the output will be 128 right shifted by 5. So that is equal to 4. So 125 means, that means 2 times 2 raised to 5. 2 raised to 5, 25, 10, 32 and then 4. So 120 by 32, that is equal to, sorry. So example, let's assume once again. So let's assume number is 128. If we shift the number 5 position to the right, the output will be 128 right shifted by 5, that is equal to 4. Now, so program using bitwise right shift operator, bitwise right shift operator in Python, variable 128. So variable that is in right shift 128, same value. Variable position by 1, so 1 position to the right, that is a 2 position to the right, 3 position to the right, 4 position to the right, and 5 position to the right. So we can check with this one. So so variable 122.8, then there is 2, and we get 128 by 2. So if we increase the number, here we get division value by 2 raised to n. Okay, so similar way we can complete this particular example, whatever the shifting operation you are required. So that is from this right shift operator. Now last one is a bitwise ones complement operator. So ones complement operator will invert the binary bits. If a bit is a 1, it will change it to 0, and if the bit is 0, it will change it to 1. Example, let's take number 4. So then bit number 1's complement of 4 will be, so first we have to set what is 4 binary value. So this is for sake of simplicity. So 0 0 0 0 0 1 0 0 binary operation. Now complement, one complement, so whatever the value of 0, it will be 1, and 1 will be 0. So 1 1 1 1, this one is 0, and this 1 1. So it will convert all 1 to 0 and 0 to 1. So this is bitwise complement operator. 4, that is equal to 0 0 0 0 1 0 0, that is equal to 4. Now one complement is 1 1 1 1. 0 is 1 1 0 1 1. So that is, this is a negative part of -5. So this is -5. How it actually we got -5? So let's to this example. So let's look to how is -5 is stored in computers. As we discussed earlier, negative numbers are represented by using 2's complement form. So minus will be stored like this. So first 5 is 0 0 0 1 0 1 2. First complement of 5 is all zeros are 1 and ones are 0. So 0 is 1 0 1 1 is 1 1 1 1 1 0 1 0. Then add 1 to get the 2's complement. Okay, so -5. Now add 1 here to get 2's complement. So last add 1. So 1 0 1 0 is added to 1 0 1 1. Okay, so result of 1 complement minus 4, 1 combination 4 is equal to, representation is -5 in binary. Hence 1's complement 4 is -5. This is the example second. Let's take a number 2. So 2 binary is 4 times 0, then 0 0 1 0 2. First complement of 2. So 1 1 1 1 1 1 0 1. Add 1 to get 2's complement. So add 1 to get 2's complement in this case. So 1 1 1 1 0 0. So result of 2's complement is equal to the representation of -3 in binary. Hence negate of 1's complement 2 is -3. So how bitwise 1's complement operations Python can be checked. So variable equal to 3, and if we check here, we want that 1's complement of variable, so that is equal to minus 4, or we can also see this particular example like 1 square meter minus 4. So let's okay, so answer is minus 5. So that is from this bitwise operator. Hope you enjoy this. If you found any kind of difficulty or doubt, you can raise your comment in this particular comment section. Otherwise, you may like, subscribe this channel. Thank you. Enjoy your day. Reference here is noted. log2base2.com is the reference. That is all the discussions covered from this